Hello, everybody. In this video, we're going to go through a lesson on solving quadratic equations. And to start us off, I'm going to kind of create and go through a flow chart that I think will be very helpful as you encounter quadratics. So when you are writing this, please try your best to put this in your notes and create this somewhat like how I create it, so that way you can use this for your own reference. So when you are starting with a quadratic, you are going to be asked to solve some ax squared plus bx plus c is equal to 0. And it may or may not be exactly in that form, but your job is to kind of figure out what's missing. How do we get it to that form? What can we do? So where do we go from here? You're asked to solve. So the first thing I want you to look at and ask yourself, is my b value equal to 0? So look at your b value. Is it equal to 0? And let's imagine for a second that b is actually equal to 0. So if it is, then I don't have a b term. So maybe I have like ax squared just plus c is equal to 0. Or oftentimes we might see that form that doesn't have the expanded trinomial. Maybe it's like x plus m squared equals n. Those two forms here both can be solved in the same way. We can solve with square roots. So if you do not have that b term, woohoo, you can solve with square roots. Oh, let's see if that's gonna, oh, I love that. So we're gonna solve with square roots, and that's gonna get us our solutions, right? We're gonna have x is equal to a number, or x is equal to a number. And since we're solving with square roots, it's probably gonna be plus or minus some number, right? So we'd have the positive and the negative roots. Okay, so that's if b is actually equal to 0. What if it is not? So we have an ax squared plus a bx plus a c is equal to 0. We have this trinomial. So where do we go from here? Now I'm going to ask myself, okay, what's going on with a? Is a equal to 1? So that is the next question I'm going to ask myself. So if a is equal to 1, that is lovely. If a is equal to 1, then we have just some x squared plus bx plus c is equal to 0. And this is wonderful because you can try to factor using x factors. So x squared plus bx plus c equals 0. If a is equal to 1, ask yourself, can it factor with x factors? So can you factor it using those x factors? So if you can factor it with x factors, let's see, we're gonna go like this. I'm being intentional with the space on the other side because we have another case if a is not equal to 1. So if you can factor it with the x factors, wonderful, then you are going to do that. You are going to factor, and you are going to use that 0 product property. So I'm gonna have some x plus a p, some factor x plus q, some other factor, and that is equal to 0. That's the key. It has to be equal to 0. And then we can use the 0 product property. Good enough. We can use the 0 product property to get that x is equal to something, or x is equal to some other number, right? Could have up to 2 solutions. So let me just kind of fix this. Okay, now that is if it is factorable, right? So If it's not factorable, if we cannot factor and use that zero product property, what do we do? That is when we then try to complete the square or use the quadratic formula. All right. And once you do that, then you will get your solutions, right? X is equal to something or X is equal to something, right? When you complete the square, use the quadratic formula. Or you might get that there's no solutions. Now, this is all, if A is equal to 1, let's just consider the other possibility that A is not equal to 1, meaning we have some leading coefficient, some AX squared plus BX plus C is equal to 0. Now, I need to kind of move over a little bit. I'm going to use the panning hand and see. There we go. I'm going to do it like, oh, you know what I can do instead? I'm just going to zoom out a little bit. How about that? Oh, perfect. All right, so if A is equal to 1, we can factor using the X factors. If not, what can we do? We can try, can it factor by slip, slide, and divide? So if you have that leading coefficient in front, that's when we try to factor by slip, slide, and divide. And if it can factor in that way, great. Factor it and use the zero product property to get your solutions. Now, if it cannot, then you will complete the square or use the quadratic formula to get your two solutions. X is equal to blank or X is equal to blank. Note that if you have some leading coefficient, some A in front, when you complete the square, you got to get rid of that. You got to divide it out. So completing the square with a leading coefficient can be rough. Now, I do want to note that an alternate solving method exists. And I got to zoom back in. So much better. All right, alternate solving method. You can always, always, always graph. Graph and find the x-intercepts. So your x-intercepts, those are what we consider to be the solutions, right? X is equal to blank, X is equal to blank. Those are your x-intercepts, your solutions, otherwise known as your roots, otherwise known as the zeros of the function. I never remember if there's an E in that word or not. So I sincerely apologize if I just misspelled that. But graphing always works. So if I, have my XY plane and I am told to graph, for example, the equation y equals x squared, or not, sorry, y equals x squared equals 0, because that's an equation. I could graph that and it would cross at exactly one place. And that one spot is our solution. So a lot of quadratics cross at perhaps two places. Maybe I have x squared minus 4x plus 3 equals 0. And this is going to cross at two different places. I think it would cross at 3 and 1, perhaps. So the two places where you cross, those are your solutions, your x-intercepts, your roots. your zeros. I don't know if that graph's exactly relevant to that equation, but this is just an example. When you graph it and it's a quadratic, it will make this parabola shape. And where you cross the x-axis, those are your solutions. All right. Now I also want to talk about your types of solutions. Do that in pink. So a quadratic equation can have no real solutions or zero real solutions. There might be imaginary solutions, but no real solutions. Your quadratic equation might have one rational solution, meaning one fraction, decimal, whole number solution, not a crazy long decimal that goes on forever. It could have two rational solutions, or you could have two irrational solutions. So these are the possibilities. And how do we determine how many we have? You will always use the discriminant. Discriminant to determine the number and type of solutions. So if you do not remember, your discriminant is that b squared minus 4ac. So if this is a positive number, then you are going to have two solutions. If it's a positive number that's a perfect square, you're going to have rational solutions. But if it's not perfect, it'll be irrational. So use your discriminant and notice, it comes with playing around with this a lot. You will notice that number underneath the square root can either make the square root go away completely, or it can really make things worse. And if it's negative, then we have no real solutions at all. All right, I want to do just one example here working with quadratic equations. So a painting has an area of 4 feet squared. The width is 2 less than a number, and the length is that number plus 1. Write and solve an equation for x, the unknown number, used to find the length and width. All right, so this word problem actually doesn't really need a picture. It doesn't come with a picture. We could piece this together on our own. So this painting has an area of 4 feet squared. The width is 2 less than a number, and the length is that number plus 1. So this is just a rectangle, right, with a length and a width. So let's just fill in our pieces. The width is 2 less than a number. So I am going to take that number, right, x, because that's the number they want us to use, and I will subtract away 2, right? That's 2 less than that number. If that number's 5, then 5 minus 2 is 3, which is 2 less than that, right? Now, if I want to take that number plus 1, that one's a little bit more straightforward. It would just be x plus 1. And we know altogether the area of this painting is 4 feet squared. Now, knowing what we know about rectangles, the area is always going to be the length times the width. So I could write an equation here. We know our area is 4 feet. So 4 is equal to our length, which is x minus 2, times our width, which is x plus 1. I think I kind of did that backwards, but it doesn't really matter. I think our width was x minus 2, right? And our length was x plus 1. The order doesn't really matter when we're multiplying here, okay? Now I'm going to multiply because this is equal to 4. If it were equal to 0, I could use the zero product property and just split these factors up, but it's equal to 4. So let's go ahead and multiply this out. So I have a binomial, 2 terms multiplied by a binomial. So I can just use FOIL for this. I'm going to start by multiplying x times x, and x times x will give me x squared. So we have 4 is equal to x squared, and then I'm going to multiply the outside terms. So next I'm going to multiply x times 1, which is just 1x. So x squared plus 1x. Then I'll multiply the inside terms. So I'm going to multiply negative 2 times x, which is negative 2x. So now I have minus 2x, and finally I'll multiply the last 2 terms, negative 2 and 1. And negative 2 times 1 is negative 2. So I have 4 is equal to this x squared plus 1x minus 2x minus 2, and I can combine some terms here. I can combine the 1x minus 2x, and that will give me negative 1x. So we have 4 is equal to x squared minus 1x minus 2. And if my goal is to now solve for this variable, let's try to get this equal to 0. So I'm going to now move this 4 over by subtracting 4 from both the left side and the right. So I would have to subtract it from the negative 2 over here. So now I have 0 is equal to x squared minus 1x, and then negative 2 minus 4 will give me negative 6. And now this is an equation that I can factor, or I could even put this in Desmos and I could figure out where the x-intercepts are, where we cross the x-axis. But I'm going to factor this real quick. This is a trinomial where x is 1, so I'm going to try to find my x factors, meaning I want numbers that multiply to negative 6, but add to negative 1, right? Because our c value is negative 6 and our b value is negative 1. So thinking about numbers that multiply to negative 6, it's, negative 1 times 6, or maybe negative 6 times 1. We have negative 2 times 3, and negative 3 times 2, right? We have at least one of them, or actually only one of them has to be negative. And if I look at the sets, which one will add to negative 1? And that is negative 3 plus 2. Negative 3 plus 2 gives me negative 1. So negative 3 and positive 2 are my x factors, which we can use to factor. So we know now that 0 is equal to these two factors, x minus 3 times x plus 2. And now I can use the zero product property, right? This is equal to 0. We have these two terms being multiplied, so let's split them up. I can say either x minus 3 is equal to 0, or I can say that x plus 2 is equal to 0. And then we will solve. So for the first equation, to get rid of the negative 3, let's add 3 to both sides. So this will tell me that one of my solutions is 3. And then the other solution, x minus 2, means we would have to subtract 2 from both sides to get negative 2 as our solution. Now, in a real life context, negatives often don't make sense. So let's think about it. Remember our width. That was x plus 2. And then our length, oops, so nope, nope, nope. This was x minus 2. And then the length was x plus 1. If I substitute the value of x equals -2 in for the width, this means our width would be -2 minus 2 or 0. And our length, well, that would be -2 plus 1, which is -1. We can't have that. There are no negative lengths or widths. So this negative x value is not a valid solution here. So the only valid solution to this problem is that x is equal to 3. So oftentimes in your real world problems, you will just need to consider the positive. Not always. Money can be negative, depth can be negative, but in this situation, you can't have negative length. You can't have a length of 0, that's nothing. So the positive solution makes sense here. Please let me know what questions you have.